Today's video is going to be our second day we're going to spend on 2.7 on piecewise functions. So we're going to start by graphing a piecewise function. We've got 4 pieces to this piecewise, and the way we talked about in the last video was we're going to start with the y-intercept of 5, and we've got 3, 4, so we're going up 1, 2, 3, right 4. You can also go down 3, left 4. And we actually graphed the whole equation and then we looked at our bounds. What we're going to do today is kind of take a different approach. You can still use that approach, but we know we want all of our x values when they're less than negative 8. So what I'm going to do is I'm going to plug 8 into the equation, and we get that 3/4 times a negative 8 is a negative 6 plus 5 gives us a negative 1. Therefore, at this point, we plugged in an x value of negative 8. We got out a y value of a negative 1. So the first point on that graph is going to be negative 8, negative 1. Since it's less than, we're going to have an open circle. Now, we would have gotten the same answer if we did our slope of 5, down 3, left 4, down 3, left 4. You notice that we stay at the exact same point. This approach kind of allows you not to have to graph the entire line. It lets you look only at the piece that you need. Now we want our x values to get less than negative 8. The way that x values are less is if we go left. So we want to go down 3, left 1, 2, 3, 4. So there's going to be our first piece of our piecewise function. Our second piece, we want it between a negative 8 and a negative 6. So we start by plugging in the negative 8. Oops. We've got a negative 3/2 times x, which is a negative 8, minus 7. A negative 3/2 times 8 is going to give us 12 minus 7, which is 5. So this point right here is going to be a negative 8, 5. That's going to be the left-hand side of our graph. We also need that second point at negative 6. So a negative 3/2 times a negative 6 minus 7. That's going to give us 9 minus 7, which is going to be 2. So that point's going to be at a negative 6, 2. So we go to a negative 8, positive 5, our first point. Our symbol is less than or equal to, so I'm going to have a closed circle there. And then our second point is at negative 6, 2. So we go negative 6, 2. We have a less than, so that's going to be an open circle. And our second piece of our piecewise function is right there. We only want that one little segment of that line. Our next line is x plus 6 between a negative 6 and a positive 2. So we plug in our negative 6. We've got x plus 6, so negative 6 plus 6. That's going to leave us with 0. So that point is going to be at a negative 6, 0. Your second point is at 2. 2 plus 6 is 8. So your point there is going to be at 2, 8. We see that both of them are less than signs, so both are going to be open circles. So negative 6, 0, open circle. 2, 8, open circle. And it's going to be everything in between there. You also can use your slope. You know you have a slope of 1, so it's going to be up 1, right 1, up 1, right 1. And you can see how my line isn't that straight. There you go. Now our last piece of our piecewise function, we want it for all x values greater than or equal to 2. So we've got negative 3/2. Our x value is 2 plus 12. Negative 3 plus 12 gives us a y value of 9. So this point is at 2, 9. It's greater than or equal to, so we're going to have a closed circle at 2, 9. And we want it to be everything greater than or equal to. And our middle two pieces, we had a left bound and a right bound, so we didn't have to worry about building our line. Now we have only one bound, so we need to build our line where an x is greater than or equal to 2. So if I want my x values to be greater than or equal to 2, I want to go to the right. So if I build my slope, it's a negative 3/2. I go down 1, 2, 3, right 1, 2. Down 3, right 2. Just make sure that when you're doing your slope, you're building it in the correct direction using the correct slope. So there's our first piecewise function. Let's review our step functions from yesterday. Our step functions are, we don't have these different slopes of our lines. In this case, we're going to have 1, 2, 3, 4 horizontal lines. Our first horizontal line is at 8, and we want it to be when x is less than -7. So we know that our horizontal line at 8 would be there. We don't want the whole thing. We only want when x is less than -7. So we've got our line at 8, our x-coordinate -7, it's an open circle to the left. Our second piece, we want a horizontal line at 6 between a -7 and a -3, where the -7 is closed and the -3 is open. So our horizontal line at 6, we're going to start it at -7, closed circle, all the way to a -3, open circle. Next piece, horizontal line at 3, from a -3, closed circle, to 0, open circle. Horizontal line at 3, closed circle at -3, open circle at 0. There's our third piece. And our last piece is a horizontal line at 1, and we want it to be greater than or equal to 0. So we've got a closed circle at 0, everything to the right. Alright, so there is review on graphing. Now we're going to write an equation given a graph. So when I look at this right here, I am going to have a step function because they're all horizontal lines. If I'm writing a step function, it's going to be very similar to number 2. Notice that in order to be an equation, you have to have the f of x equals. So I'm going to start with the f of x equals. We know we're going to have 1, 2, 3, 4 lines. Those lines are at a -4, a -6, a -8, and a -10. Now we need to fill in the bounds for those lines. And we see that it's separated by if and then the bounds. So we want it to be at -4 if we have a bound between -7 and -5. So we know -7 is going to be there, -5 is going to be there, x is going to be in the middle. We have an open circle at -7, so that's less than, closed circle at -5, less than or equal to. We move to number 6. If our left bound is -5, our right bound is -3, so we know we got -5 there, -3 there, x is in the middle. Open circle at -5, closed circle at -3. So we've got open circle is less than, closed circle is less than or equal to. Now I want you to press pause, complete the bounds for -8 and -10. When you're done, press play to see if you were correct. Alright, check to see how you did. We had an open circle at -3, so it was less than, closed circle at -1, so it was less than or equal to -1 for the horizontal line at -8. For our horizontal line at -10, open at -1, closed at +1, so it was -1 is less than x, which is less than or equal to 1. Alright, moving on to our last problem. This is a word problem. The prices of a photography or photocopy shop called Dynamite Dittos can be modeled by the function. And we have a piecewise function here. And we've got 0.15x when x is between 0 and 25, 10x when it's between 26 and 100, 0.07x when it's between 101 and 500, and 0.05 when it's greater than 500 or 1. Now what this actually means is if you go into a copy shop like Kinko's or Dynamite Dittos, the more copies you make, the better the price it's going to be. So this is saying that it's going to be 15 cents for every copy you make if you're making between 0 and 25 copies. You can't make less than 0. You can't make a negative number of copies. Now if you bump it up and you make between 26 and 100 copies, you're going to pay a cheaper price. You're only going to pay 10 cents per copy. and so on. So if I have between 101 and 500, I'm paying 7 cents a copy, and if I make more than 501 copies, I'm only paying 5 cents a copy. So the more copies you make, the cheaper you're going to pay per copy. So looking at the function, how much would you pay for 450 copies? This is when you look at your bounds. This is between 0 and 25, between 26 and 100, between 101 and 500. So this is where our 450 copies is going to lie. So I know that I'm going to pay 7 cents a copy when my number of copies is between 101 and 500. So if I were to use this function rule and I plug in 450 copies, I would actually pay $31.50 in order to make 450 copies. Alright, so what I want you to do now is we're going to take that step function, or that piecewise function, and we're going to draw a graph. Now we know that the x's, in this case, the x-axis is representing the number of copies. And we know that the y-axis is going to represent the cost. When we just used our equation just now, we plugged in the number of copies and we got out the cost. So what we're putting in is the independent, what you're taking out is the dependent. Okay, so now what I want you to do is take those two 4 piecewise functions and graph them, make an appropriate scale. When you're done, press pause and see, or press play and see how you did. Alright, I made the screen a little bit smaller here so you could see everything at once. The first thing I did for my first piece was find the bounds. If I plug in 0, I get 0, so if you don't get any copies, you don't pay anything. If I make 25 copies, I'm going to pay $3.75. So there's my first piece. And then I do the same thing. I plug in 26 copies, it's going to cost me $2.60. 100 copies cost me $10. I plot those. And so for the 101 copies, it will cost me $7.07. 500 will cost me $35. There's your big purple line. And then finally, 501 copies is going to cost me $25.01. So we've got our piecewise function. Our last question here says, using your graph, describe why paying for the amount of copies asked for in Part A is not a good deal. So in Part A, we said that 450 copies was going to cost us $31.50. The reason why this isn't a very good deal is we just found out we can get 501 copies for $25.05. So it doesn't make any sense to get 450 copies and pay almost $6 more when we can get 51 more copies for that much cheaper. So think about this the next time you're shopping and you have a deal. It's like get 5 for this price or 10 for this price. Think about if, even though you may only need 10 of something, if you buy 15 of it, maybe you'll actually get it cheaper. So think about this when you're at the grocery store, if you're at the store, when they have these kind of deals that stagger the price depending on how much you buy. Alright, and that's it for today.